Good evening, participants. It's giving me a great pleasure to welcome you all for the day 4, session 5. Today, our respected guest is Dr. P. Indra. She is currently working as associate professor and head of the department at Government College of Engineering, Thanjavur. Ma'am has around 25 years of teaching and research experience. Ma'am has completed her BE in Electronics and Communication Engineering from Anna University, and she also completed her ME in Applied Electronics from Satyabama University. She has done her doctorate in Information and Communication Engineering from Anna University. She has more research papers in international and national journals and conferences. Our main areas of interest are image processing, artificial intelligence, and deep convolutional neural networks. We are very truly happy and honored to have her with us today. On behalf of all, I extend a warm welcome to you, ma'am. We look forward to your inspiring talk. Okay, ma'am, we can start, madam.
Okay, thank you, sir. Thank you very much for your invite.
Okay, madam. Thank you, madam. Okay, ma'am. We can start.
Good evening. Good evening, all. Good evening, all participants to the ATAL online 6-day faculty development program. So the thrust area is advanced computing, supercomputing, and AI data science. So for the past 3 days, various topics were discussed by various experts. So in the first day, Dr. S. Prabhu discussed regarding introduction to Industry 5.0, and he also discussed the fundamentals of artificial intelligence and machine learning. So in the second day, Dr. Jiva discussed the concepts underlying deep learning and neural networks. So in the same day, Professor D. Mani Bharati gave an idea and what are all the available tools and platforms for AI and ML development. And in the third day, Dr. Priyan discussed human-centric AI for collaborative robots and predictive maintenance using ML in smart manufacturing. So in today's session, I am going to give a lecture in AI in smart supply chain and logistics. So this is completely it will be of theory only, no equations, no analysis and all. So only theory part, AI in smart supply chain and logistics, and how AI is utilized and how AI improves the smart supply chain and logistics. And I discussed one specific application for smart supply chain and logistics. So I'll start my session. So although you have idea of artificial intelligence, I give some basic introduction. So artificial intelligence is the technology and field of study that enables machines and computer system to simulate or replicate human intelligence. So this includes the ability to learn from data, recognize patterns, make decisions, solve problems, understand and interpret language, perform tasks that typically require human cognitive abilities. So for cognitive abilities in the sense such as reasoning and perception. And AI works by processing large amount of data. Yes, that at this point also all of you know, using algorithms and models. So machine learning, a key subset of AI, involves training models on data to identify patterns and improve performance over time without explicit programming for each task. So next one is generative AI. So I want to give an intro to generative AI. So this is a more recent category. that can create new content like text, images, or music by learning from existing data patterns. So AI is applied across many domains. So some of the domains I mentioned here. So in the healthcare, diagnosing diseases, in the finance domain for fraud detection, and in the customer support domain, chatbots. So these will be chatbots will be discussed in the later slide. And the transportation domain for that is the transportation domain means self-driving cars and the personal virtual assistants like Siri and Alexa. So it underpins many advanced technologies such as large language models, recommendation systems, and computer vision. So next, my topic is supply chain and smart supply chain and logistics. So what is AI and what is generative AI and what are all the various domains which uses AI, I told. So what is supply chain? So supply chain is the complex logistics system that consists of facilities that convert raw materials into finished products and distribute them to end consumers or end customers. So logistics, in general, you know what is logistics. So I want to define the logistics in terms of something. So raw material to finished products to end customer. And the supply chain management deals with the flow of goods, that is the raw materials in distribution channels within the supply chain in the most efficient manner. So a supply chain is a network of people, companies, resources, activities, and also the technologies involved in creating and delivering a product or service from raw material to the end consumer. So the effective supply chain management aligns these components to minimize cost. So ultimate result or end result may be to minimize costs and improve production speed and quality, and also to respond to customer demand and market changes. So this supply chain plays a critical role in business competitiveness and customer satisfaction. So this is the supply chain network, or these are the elements present in the supply chain. And supply chain management. So what are all the 7 key components of supply chain management is shown here. So first one is planning. First and more important thing is planning. Next one is sourcing and manufacturing and logistics. So this is the logistics is the subsystem of supply chain management. And inventory management and information system and risk management. So these 7 are the 7 key components of supply chain management. So AI subfields related to supply chain. So we are talking about AI in smart supply chains. So AI subfields related to supply chains are listed below. So machine learning. So machine learning, as you know, that is used for demand forecasting. In the case of supply chain management, machine learning is used for demand forecasting, inventory management, and supply chain optimization. So optimization by analyzing large data sets to identify patterns and predict future outcomes like demand fluctuations and supply disruptions, or etc. So next subfield is supply chain decision intelligence. Yes, this is also one of the main subfield. So supply chain decision intelligence combines AI analytics and cognitive predictions to provide actionable recommendations for strategic, tactical, and operational decision making, which improves the efficiency, and in turn it reduces the costs across the supply chain. So next one is NLP. When chatbots discussion, we will I will show how NLP is utilized in chatbots. So natural language processing and automation. So natural language processing and automation talks about which automates routine communication and task management, such as the handling of supplier inquiries and updating delivery status, and what else, and managing purchase orders. So by doing this, the workflow streaming will be done, and which results in reducing delay. And the next one is predictive analytics. So predictive analytics enables the maintenance for equipment used in supply chain logistics, and forecasting potential failures before they occur to prevent downtime and ensure smooth operations. So predictive analytics also will be discussed in the later slides. And the computer vision, you all know, we employed in warehouse and quality control operations to monitor the inventory, to monitor and also as well as to maintain the inventory system and detect the defects of the materials and optimize layout for faster order fulfillment. So next one is generative AI. Yes, generative AI, I gave a small introduction. So that generative AI helps in resource management and improving workspace productivity by creating tools like AI copilots, which assist workers in finding information and automating very complex workflows and all. And optimization algorithm, yes. Optimization, any algorithm need to be optimized and applied. This is applied in routing and logistics. So routing also will be discussed with examples. So AI analyzes variables such as traffic, weather, and delivery constraints to recommend optimal shipment paths and cutting fuel cost and improving delivery times. For that, the algorithm need to be optimized. So optimization of algorithm is one of the AI subfields. And next one is end-to-end visibility and cognitive automation. So end-to-end visibility is this leverages AI to integrate data streams across supply chain models. Yes, and various nodes to detect bottlenecks and enable real-time data-driven corrective actions also. Next one is risk management and demand sensing. Yes, risk management is very much important. So what a particular example I am going to discuss should have risk management and demand sensing. So that is, AI predicts supply chain risks from market fluctuations or supplier failures and senses near-term demand to adjust upstream activities with agility, reducing waste and improving service levels. So these are all the main subfields related to supply chain. And this slide talks about modern supply chain. So artificial intelligence is increasingly important in modern supply chains. So this is due to the many reasons which you listened for the past 3 days, and as you already know also. So due to its ability to automate, optimize, and enhance various supply chain fluctuations. So AI can automate repetitive and error-prone administrative tasks. So for this, we can consider what that is invoice processing and purchase order management, freeing up human workers to focus on higher value activities such as demand planning or the supplier negotiation. So the automation process is the one reason, and also AI enhances supplier relationship management. This is done by evaluating the supplier performance and flagging risks, improving the collaboration and efficiency. So when we are talking about the machine learning models, so the machine learning models enable better demand forecasting. What is demand forecasting also will be discussed, and inventory management. So that will also be discussed with discovering complex pattern in data, which helps prevent issues like the bullwhip effect. So bullwhip effect that can be simply it can be considered as large upstream supply fluctuation caused by small changes in consumer demand. That is bullwhip. So that is a phenomena in supply chain management, where small fluctuation in consumer demand and the retail at the retail level are amplified as they move up to the supply chain. So this leads to exaggerated the demand. So only the requirement is small, but it will be exaggerated the demand signals and increase the inventory shortages at the management or manufacturers or supplier level. So that is one main thing. And leading companies like Amazon demonstrate AI's value with examples of AI-driven demand forecasting, warehouse robotics, packaging optimization, and damage prevention, which have resulted in faster delivery times. Yes, Amazon, so faster delivery times, cost savings, and reduced environmental impact. Moreover, AI integrated with digital twins allow simulation and optimization of complex supply chain process. This improves the planning without disrupting. Yes, this integrated with the digital twins and the simulation result allows you to plan without disrupting the real operations. So these capabilities provide unprecedented visibility, agility, and efficiency, and this gives all to manage today's global supply network. So this is modern supply chain regarding. These are the points I wanted to tell. And yes, what is logistics? So in the first itself, I told you regarding logistics. So logistics refers to the overall process of managing how resources are acquired. Resources, yes, raw material are acquired, stored, and transported to their final destination. So this logistics, so in the key components of supply chain management, one of the component is logistics. So logistics is the fundamental component of supply chain management, and this focuses on the efficient and the effective flow and the storage of goods, services, and related information from the point of origin to the point of consumption. So when we are talking raw material from the manufacturer to the end user. So point of consumption to meet the end user requirements. So logistic management involves identifying prospective distributors and suppliers and determining their effectiveness and accessibility. So often these are used interchangeably. So logistic is a part of the broader supply chain management. And this integrates and manages the entire network of activities. and partners involved in drinking. Who are all the stakeholders, or what are in the network, who are all available. So bringing product or services to the consumer from the raw materials to final delivery. So this is the logistic is the operational discipline within the framework that executes the physical movement and shortage. Not the physical movement and the inventory management system, right? And why AI matters in logistics? So logistics can be done without AI also. So why AI is involved with the logistics, or why AI is used in logistics systems or in supply chain management? Why AI is introduced? So this AI transforms logistics by making operations very smarter and very faster and more resilient, that is withstand or recover very quick, and also main thing is cost effective. So in the logistic, when we introduce the concept of AI, it gives these following advantages: smarter, fast, makes the process smarter, faster, and you withstand for easy withstand storm or recovered back easily. That the resilient can have the meaning of that, and cost effective also. So this is what the particular domain I took to explain the supply chains and logistics and what are all the various topics on and or subtitles or sub components in supply chains. So the healthcare supply chain is a complex and extensive network of systems, layers, processes that ensure the manufacturing and distribution and the delivery of medicines, medical supplies, equipment to patients, and healthcare facilities. So it involves multiple stakeholders. So stakeholders, multiple. So that multiple stakeholders, we in general, the stakeholders is manufacturer. The stakeholders are manufacturers, distributors, and because I am talking about healthcare, pharmacies, hospitals, and healthcare providers, whoever maybe healthcare providers, insurers, and working together to ensure timely access to essential medical products. That is very important. So this network is highly regulated and designed with built-in protections to handle disruptions caused by pandemics or natural disaster or geopolitical issues. So whatever may be the reason, some instance may be very risky. So in that time also, this supply chain should be very or the supply chain will be very crucial to take decision, and how the inventory management will be forecasting, how demand forecasting, how it can be arised. Like that, many things are there in the case of healthcare supply chains. And key elements of the, as I already told you, key elements of the healthcare supply chains are manufacturers. So manufacturer in the sense who are all manufacturing or producing medicines and medical devices and personal protective equipments. Also, they comes under manufacturers, and distributors and wholesalers means who purchase and stock the products and distributing them to the pharmacies, hospitals, and wherever it is necessary, and the clinics, and where it is the medical emergency is required, the distributors and wholesalers can be delivered. And healthcare providers. So they are receiving and managing some inventory management system and administer the supplies to the patients. So this is also one of the important thing, inventory management, and third-party logistics providers and the group purchase organizations. So they are supporting procurement and delivery. So that is group purchasing organization are the one who are supporting procurement and delivery. And the strategic planning, forecasting, and quality control. These are for optimizing supply availability and regulate the compliance. So these are all the important or key elements we can consider that are the key elements of the healthcare supply chains. Chain. So, what are all the in any system there will be pros and cons, and compulsory whenever there is a new thing or new system or new development is there, compulsory there will be some challenges. So, in the healthcare supply chain, what are the challenges? Is complexity of sourcing globally is one of the challenge, and vulnerability to disruption. So that is natural disaster, geopolitical and the pandemic situations, and rising costs also a very big challenge in healthcare supply chain. And these need to maintain regulatory compliance and quality standards. So, in this regard, recent advancement focus on integrating digital tools like artificial intelligence, AI, cloud systems, and blockchain for improved forecasting, transparency, and efficiency. So, sustainability, resilience, and risk management are priorities for future healthcare supply chains. So at present, some more challenges are there, and in future healthcare supply chains, priorities need to be given for sustainability, withstanding capacity should be more, and risk management should be increased. So in the future supply chains, for better respond to ongoing and emerging challenges, ensuring continuous patient care delivery. So, and also healthcare supply chains are very unique also. Yes. In what way it is unique? Why it is unique? So this is first point is the healthcare supply chain is patient and high stakes. So unlike retail of other things, in healthcare, the supply chain is patient centric. So unlike retail, where stockouts may merely lead to loss or that is profit may be reduced or lost, sales may be lost. But in the case of healthcare, shortages there means that will lead to very danger or very critical position, and here the question is about the patient's life. So every delivery directly impacts treatment and outcomes. So that is the one point. This healthcare supply chain is unique. Next one is specialized product and requirements. Why specialized product requirement? So some vaccines, so some healthcare supplies like vaccines, biologics, or surgical tools, which require strict temperature control. So that in general, all of you know that some of the medicine need to be kept under some temperature, and also the vials or something, whatever it may be, the vaccine should be handled handled clean, and rapid delivery should be there, making the logistics especially demanding also. Many items also have short shelf lives, requiring precise inventory turnover also. This is one of the specialized products. So in the healthcare supply chain, this is the this is the second point why healthcare is very unique. And next one is regulatory intensity and traceability. So healthcare is one of the most heavily regulated industry. So from pharmaceutical safety standards to device tracking, regulatory compliance is non-negotiable. So there we cannot compromise with the standard or quality or something. So what are the standards prescribed? That should be there, and temperature should be less, means that should be maintained. So regulatory intensity and traceability is another thing. So and products must often be tracked by lot, serial number, potency, and purity to enable recalls and quality control. So traceability should be there by making use of lot. So nowadays, in previous days, nobody might done. So, but nowadays we all will check the manufacture date, expiry date, and all, and not the lot number or batch number we are not checking, but the manufacture date and expiry date compulsory, all of us will check. So that quality control should be maintained. So for that, regulatory intensity and traceability should be there. So also this healthcare supply chain is unique. And the fourth one is complex ecosystem and fragmentation. The healthcare supply chain spans multiple stakeholders, as I already told you: manufacturers, distributors, group processing organizations, and hospitals, clinics, any that is clinic and government agencies, creating high fragmentation and coordination challenges also there in the case of healthcare supply chain. So this is another point why healthcare is unique. And the fifth one is demand volatility and forecasting challenges. So demand volatility. So volatility is nothing but the fluctuation, unpredictability. There will be some fluctuation in the demand. So demand in healthcare often fluctuate due to disease outbreaks. That may be there are many reasons for unpredictability fluctuates or demand arises. So due to disease outbreaks or emergencies or seasonal variations such as pandemic surge, so like that demand may be there. And forecasting challenges is very complex. So under forecasting risks, dire shortages, while over forecasting leads to waste. Yes, so forecasting should be proper. So demand forecasting should be proper. If the forecasting, under forecasting risks dire shortage, yes. If the demand availability is less, means we are that is the patient's life is a question mark again. But while over forecasting, the demand forecasting, it is over, means that leads to waste and expired supplies. And next one is visibility and data silos. So visibility, that is poor end-to-end visibility across the supply chain leads to inefficiencies, difficulty in tracking products, and potential delays. So data silos, so what is data silos is nothing but isolated pools of data within an organization, but they could not be able to access by other department. So this may be due to many reasons, separate systems or legacy technology or mergers policy or organizational culture, whatever it may be the reason. In the organization, one department cannot access the other department data. So data silos is another important thing in the supply chain management. So next one is that is a fragmented system hinder real-time tracking and decision making. So the visibility and data silos are the same concept, and so this is very unique. And the next one is cyber security and data privacy. So as healthcare systems digitize, so previous 2 to 3 decades before, or maximum 2 decades or 3 decades before, no digitization of the patient's health monitoring systems are there. Patients' data, supply chain operations become prime targets for cyber threats. So now all are digitized. So this patient data and supply chain operations become prime targets for the cyber threats. So ensuring robust cyber security and compliance with standards like HIPAA or GDPR is vital. Next one, so data privacy is needed. So this healthcare supply chain is unique. And next one is escalating cost and resource constraints. So there's no need to explain. So high cost for specialized logistics, regulatory compliances, infrastructure, and training will put significant financial pressure in healthcare organization. So this will escalate the cost also in the case of healthcare. And next, need for skilled workforce. So this, so in the case of 8th point, escalating cost and resource constraint, training need to be given, and regulatory compliance should be there, infrastructure should be proper. So for all this, need a skilled workforce also. So managing such complexity requires professionals with, so that what are all the difficulties in resource constraints or escalating costs the costs need professionals with strong training and experts in the particular domain who are currently in short supply actually. So next and last one is traceability and risk management. So robust traceability systems often covered by blockchain and real-time tracking. These are essential to ensure patient safety and manage the supply risks also. So these are the reasons for considering healthcare supply chains be unique. So healthcare supply chains are not just about moving goods, and moving goods means raw materials. So they are lifeline requiring precision, coordination, and resilience or withstand the capacity. So their uniqueness stems from a blend of high regulatory burden, product sensitivity, unpredictable demand. So demand forecasting will be discussed in later slides, and a need for airtight visibility and security. So innovations in digital systems, integrated tracking, and skilled management are essential to ensure these supply chain remain robust and adaptive. So these are the important and unique reason for the uniqueness of healthcare supply chain. So core applications of AI in healthcare logistics. So demand forecasting. So over forecasting or under forecasting what can happen. So that I told. So core application of AI in healthcare logistics. First one is demand forecasting. So in the demand forecasting, AI in demand forecasting for healthcare supply enhances accuracy and efficiency by leveraging advanced machine learning algorithms and predictive analytics. And unlike the traditional methods, which may achieve around 65% of accuracy, AI-powered forecasting can reach about maybe 85% of accuracy. This is the data or statistic available from the net only. So what extent it will be accurate, I don't know. But so traditional methods, the accuracy may be 65%. But if it is AI-powered forecasting, means maybe the accuracy may be increased, and at about 85% it can be. So this is done. How this is done? This is done by analyzing vast and diverse data sets, including historical usage. Yes, AI already, AI will use very large data sets. So here also this AI-powered forecasting system will utilize the data sets, which includes the historical usage, seasonal trends, patient inflow, and how the disease outbreak or the outbreak patterns, and during the winter season, how the cold and fever, and some seasons are during this time all are having fever like that. So outbreak patterns and external factors such as weather or geopolitical events also plays a major role, and that are all considered in AI-powered forecasting for the demand forecasting. So AI in the demand forecasting, AI models dynamically learn from new data to predict future demand. Yes, demand forecasting is for predicting the future demand for the purpose of medical supplies, pharmaceuticals, and hospital resources to make it possible to give service or to provide medicines to the needy people. So AI models such as random forest, support vector machines, and deep learning architectures like LSTM, that is long short-term memory, which is a recurrent neural network, dynamically learn from new data to predict future demand. So this is the concept of AI in demand. So predict the future demand for medical supplies. So this improved forecasting helps healthcare organization proactively plan. So very well they can plan according to the forecasting. So procurement and inventory. This results in critical stockouts and overstock situations that lead to wastage. So yes, under forecasting, what can happen when under forecasting is there, or what can happen over. So in the case of forecasting, wastage or shortages will be there. So this is AI in demand forecasting. So for this demand forecasting, I want to tell you some case examples. So as I already told you, the manufacturers are the one who are manufacturing or producing medicines and PPE, that is personal protective equipment. So this case study is based on the COVID-19. So in two case studies I took, one is Ethiopia case study and another one is Sri Lanka. So in Ethiopia, at the public hospitals, in the Ethiopia public hospitals, PPE shortages were compounded by interrupted supply schedules. Yes, during the pandemic situation, transportation restrictions were very strict, and these interrupted supply schedules, logistic challenges, and lack of training on PPE. Yes, people are not well trained, and how to use the equipment and how to manage, and irrational utilization of PPE, that is repeated use of limited life mask. So that is also one. Limited life mask repeatedly used. So these are all the scenarios in the public hospital in Ethiopia. These issues underscored the complexity of managing PPE logistics in low resource setting during the pandemic, and they emphasized the need for improved record keeping, rational use policies, and timely training. So this is the first case, and in the second Sri Lanka during COVID period, what happened? So supply chain was severely impacted by global shortage. Yes, during pandemic period, the personal protective equipment chain was severely impacted because of the globe. It is the PPEs are very much shortage, and that leads to global shortage, lack of raw materials, unavailability of unavailability of certified suppliers. The suppliers may be there, certified suppliers, and delays in procurement and quality failures. So, yes, in Sri Lanka, this happened. So, to mitigate these issues, the country encouraged local production, negotiated intergovernmentally, and established guidelines for rational PPE use, and sought support from development partners. So this highlighted the need for better preparedness and local capacity building to ensure the uninterrupted protective or personal protective equipment supply during the health crisis like COVID-19 pandemic period. So, so this is what the demand forecasting is done. So doing. So demand forecasting, analyzing. So AI introduced in the demand forecasting very well without a wastage of raw materials. The supply chain manages the situation. And the next one is inventory management. So inventory management, one of the key component of supply chain management. So inventory management is the process of overseeing a company's inventory, including the ordering, storing, and selling of raw materials, components, and finished products. So a company's inventory is one of its most valuable assets. For companies with complex supply chains and manufacturing processes, balancing the risk of inventory glut and shortages is especially difficult. To achieve these balances, they may call on several methods for inventory management. So, major inventory managements, or 4 major inventory managements are there. One is just-in-time management, JIT, and another one is MRP, materials requirement planning, and another one is economic order quantity, that is EOQ, and DSI, days sales of inventory. So these are all the various algorithms used in inventory management, which is one of the important key component of supply chain management. And in general, inventory management is discussed. So AI in inventory management improves the accuracy. Yes, repeatedly that will improve the accuracy, efficiency, and the decision making. This is done how this happens. So this is by using machine learning algorithms and real-time data analytics to optimize stock levels and reduce wastage. Wastage. So AI systems analyze historical sales data, current demand trends, supplier performance, and external factors to predict optimal reorder points and quantities. So this what happens when AI system is introduced in the inventory management. This will analyze the historical sales data, current demand, and what is the performance supplier. Analyzing all these, this predict optimal reorder points and the quantities. What is the quantity required? That will be decided easily, and this leads to minimizing both overstock and stockouts. So in healthcare and other sectors, AI-driven inventory management can automatically track usage patterns of supplies, alert managers before critical items run low, and suggest adjustments. So this is based on seasonality or emerging demand spikes. This can be done by, or based on, this may be done by the seasonality. What is the demand spike? That is demand forecasting based on the demand forecasting requirement. This may be done in the inventory management. So this helps maintain sufficient inventory of essential products while cutting holding costs and reducing expired or obsolete stock. Additionally, AI enables intelligent automation in warehouse operations such as dynamic sorting, smart replenishment, automated order picking, which further increases the supply chain responsiveness and accuracy. Yeah, so this inventory is also one of the main key components. So once intelligent automation is introduced in the warehouse operation, it results in the enhancement of supply chain responsiveness, and also it will increase the accuracy. And next one is cold chain logistics in healthcare. So cold chain logistics in healthcare is a crucial system of procedures, equipment, and technology. So this cold chain logistics, what it is this ensures temperature sensitivity, the temperature sensitive healthcare products such as vaccines, as we already we discussed the vaccines and personal protective equipments like that. So healthcare products such as vaccines, medications, biologics, and these are stored and transported at precise recommended temperatures from their point of origin to the point of care. And this ensures the life-saving treatments reach patients in optimal condition, especially in remote areas and challenging climates. So this specialized supply chain management is vital for maintaining product efficacy, potency, and safety, preventing the spoilage of the medicines. So next one, we'll discuss what are the key components and processes. So in the cold chain logistics, what are all the key components? So we already we discussed that the temperature sensitive healthcare products need to be maintained workshopல இருக்கேன் அப்புறம் so sorry. So key components of the process of cold chain logistics are temperature controlled storage, as some of the medicines need to be kept under some temperature. So temperature controlled storage is important. Refrigerated and frozen units are used at manufacturing facilities, distribution centers, and healthcare sites to maintain products with strict temperature ranges. Next one is specialized. Important thing is storage. Next one is transportation. So for transporting this special products, specialized transportation need to be there. So this involves using temperature controlled vehicles, that may be ships or trucks or planes or whatever it may be, and that should be there, and packaging should be very special, and with the cold boxes, with the vaccine carriers to keep products cool during the transit. Next, temperature monitoring. So continuous monitoring also very much important. So using thermometers that need to be done, and digital data loggers is also essential to track and record temperatures throughout the cold chain, which identifies and deviations that could compromise the product. So in the cold chain supply management or cold chain supply chain, what is essential is that need to be continuous monitoring of the temperature, and also digital data loggers need to be maintained, so that because we cannot compromise with the quality of the product. So temperature monitoring is also important, and proper handling. So proper handling in the sense, so there are some strict procedures for handling and storage of the special medical equipments or medical medicines, special medicines, that should be followed to minimize temperature fluctuation and protect product integrity. So next one is inventory management, what we discussed in the previous topic. Effective management of stock levels and emergency procedures are in place to safeguard the medication inventories from temperature excursions. So digital data log is used. And why it is why cold chain logistics is essential. This maintains the product efficacy. It ensures the safety of the patient, and supports global health initiatives, and safeguard the investment. So in the maintains the product efficacy means temperature sensitive vaccines and biologics can lose their potency, or the quality of the medicine may be changed, and the effectiveness will be reduced if exposed to temperature. So the product, that should be maintained, the temperature should be maintained. And patient safety, yes, if that is not followed, then there is question for patient safety. So a compromised cold chain, if there is some compromise in the cold chain, means that can lead to patients receiving ineffective or overdosage or underdosage, whatever it may be harmful, harmful to the patient and directly impacting the public health. So, support the global health initiative is one which enables the distribution of vaccines and medicines to remote or underserved population. Underserved population, so a critical aspect of global immunization programs. So through some immunization program that may be transmitted or transferred or made available for underserved population. So safeguard investment is the financial investment, as I already told you. So special healthcare is unique. So we need to have trained operators or resource should be very expertise in the particular machine or medicine or whatever it may be. So the financial investment in developing and producing these critical healthcare products is protected by ensuring they reach their intended use. So, temperature sensitive products, as I already told you, vaccines, biologics, and certain medications, and importantly, organs for transplantation that will be maintained under the particular temperature. And yes, vaccines. Some of the vaccines are very much temperature sensitive, and they require continuous temperature control. And in the case of biologics, also some complex biological products will be very sensitive to temperature, and medications. Some of the medications or some of the medicines need to be in the refrigerator, or it should be maintained in the freezer, so that the quality or the dosage or the medicine may be effective. And organs transplantation, transplant, regarding that I don't need to explain. So the storage and transport of transplant organs are extremely time sensitive. Here, in the case of organs transplantation, it is time sensitive also, and also temperature dependent. So, what is cold chain logistics we discussed? So, AI in cold chain logistics. AI is transforming cold chain logistics by enabling precision, efficiency, and proactive management throughout the storage and the transportation of temperature sensitive products like vaccines, pharmaceuticals, and perishables. And next one is route optimization and emergency deliveries. So route optimization in the case of healthcare, route optimization is very much necessary. So AI-driven optimization integrates real-time and historical data. So this leads to adapt instantly to disruptions, essential in both daily deliveries and during the emergency period also. So automated dispatching, predictive analytics, and AI-powered location tracking ensures the right resources are allocated to the right place at the right time with the proven improvements in response speed. So, improvements in speed, resource efficiency, and patient care in precise conditions. So, when we introduce AI in route optimization technique, these resource efficiency, patient care, and the speed all are increased or improved. So these solutions are already revolutioning the logistics, and their role in critical life-saving supply chain operation is set to expand as AI technologies mature even further. So when AI technology is, yes, it is continuously developing. When it mature even further, this chain operation can be expanded. So these solutions are, AI in route optimization and emergency deliveries is not just about efficiency, it is saving life and ensuring continuity of care when every minute counts. So AI in route optimization, bro. So what is the reason for route optimization discussed? And this because of AI, AI is used in route optimization that ensures the real-time adaptability, data-driven decisions, and continuous learning. So multi-objective optimization, dispatch automation also possible due to the AI in route optimization. So the route optimization also deals about the ambulance and medical supply dispatch. So ambulance, so routing and emergency response that will update the live traffic, and resources may be allocated, predictive demands, that is forecast predictive demands, and precise location services also all are possible due to the due to the route optimization, AI in route optimization. And for this, I show you two case evidences. One is the cities integrating AI-based routing and traffic predictions saw ambulance response time drop by up to 30%. So when AI is introduced in the smart supply chain, and due to the involvement of AI, the response time is dropped by 30%. And during pandemic period, AI enabled matching and routing improved. Patient prioritization was possible, yes, and delivery efficiency by 40% increased. So these are all some statistics for AI introduced in route optimization. And next one is AI in personalized medicine logistics. So this plays a major role. AI in personalized medicine logistic plays a major and crucial role because it is managing the unique complexities of delivering highly tailored therapies such as gene and cell-based treatments biologics and other patient-specific medicines. So AI is AI in personalized medicine make it possible all this. And the key aspects of AI application is personalized medicine logistics include um, demand forecasting and production scheduling. So demand forecasting, already I told. So AI and machine learning algorithms will analyze the vast data set, including patient-specific treatment plans and real-time clinical data, historical data, to accurately forecast demand and dynamically adjust manufacturing schedules. So real-time supply chain visibility and tracking. AI integrated with IoT devices and blockchain technology provides transparent, tamper-proof tracking of individual therapy batches through the supply chain, and optimized distribution and logistics. So AI systems optimize the routing and delivery schedules to ensure that therapies reach patients on time and in optimal conditions, particularly critical for biologics requiring cold chain logistics. So in the personalized medicine logistics, the role of AI is very important, and adaptive and decentralized logistic models. Personalized medicine logistics benefit from adaptive models powered by AI that respond flexibility to fluctuation and uncertainties in the demand. And integration with healthcare providers, so who are all healthcare providers, hospitals, clinics, and logistic providers. So all are the healthcare providers. So AI facilities better integration and communication between these. Who are all the stakeholders we discussed? The manufacturers, logistic providers, patient. So the integration between these stakeholders ensures the patient-specific requirements and that are met precisely, improving the treatment outcomes. So this is regarding personalized medicine logistics. And next one is AI for predictive maintenance of medical fleet. So medical fleet, what is medical fleet? So fleet refers to a specialized group of vehicles and medical devices managed by healthcare organization. So in particular, I am discussing about the healthcare supply chain. Here, the vehicle used for transportation. So the managed by healthcare organization to support patient care and the deliver supplies and the transport personnel. So this includes ambulances for emergency transport. Yes, vehicles means healthcare, compulsory ambulance, and temperature control vehicles for vaccines and medications, and mobile clinics, and even specialized medical equipment like medication carts. And the effective management of these fleets involves fleet management, software to track vehicles. So to properly provide all these services, the fleet management software need to track the vehicles and monitor the driver behavior, and also manage temperature sensitive cargo cold chain, that is regarding cold chain, and ensure patient and assert safety and regulatory compliances. So predictive maintenance of medical fleet vehicles leverages AI technologies. This enhances vehicle reliability, reduce downtime, and also improves safety and lower operational costs by anticipating maintenance and the maintenance before failure occurs. And this approach contrasts with traditional reactive or routine preventive maintenance. Why it is? Because continuously monitoring vehicle health data and using AI algorithms to predict potential component failures. And advanced implementation include predictive analytics, which estimates the remaining useful life of parts, and proactive recommendation on repair timing to optimize the already schedule should be maintained. For that, it is utilized. And some systems also use Edge AI for real-time onboard diagnostics without constant internet connectivity, which is crucial for immediate decision making in critical situation. So next one is AI chatbots for logistic coordination. So how it works? So chatbots are nothing but computer program designed to simulate conversation with the human users, especially over. So all of us will use that, especially over the internet. So chatbots use artificial intelligence and NLP. In the previous slides, I told you that NLP will be referred in later slides. So for AI chatbots for logistic coordination, chatbots uses artificial intelligence and natural language processing NLP to understand and respond to user inquiries in a conversational way. And chatbots for logistics or AI-powered virtual assistants that streamline the supply chain operations by automating customer service, shipment tracking, and what else? Inventory management through natural language processing. So these tools enhance efficiency by providing 24/7 support, which reduces the cost. So improving the communication between the stakeholders, like suppliers, carriers, customers. And key application include the real-time shipment updates, automated scheduling, warehouse management, and even route optimization is also one thing. So how chatbots work? AI and NLP. So integration, also integrated logistics for automation chatbots already discussed. So key applications, what are all the key applications of AI chatbots for customer service? So this customer service provide instant responses to customer queries about order status, delivery times, and other. So if I continue, I cannot complete within 7:30. So in general, what are all the key application I am telling? Customer service, shipment tracking, inventory management, delivery scheduling, route optimization, supplier communication, and benefits. Increased efficiency, cost reduction, 24/7 availability, enhanced customer experience, and data-driven insights. And challenges, what are all the challenges, risks and ethical concerns? So bias and disparities in AI models. So origins of bias in AI models. So AI models in healthcare logistics and clinical decision making have the potential to revolutionize the outcomes, but they can also amplify or perpetuate existing disparities if bias is not carefully addressed. So how the bias arises, what are all its impacts, and best practices for remediate for the bias will be discussed. So data origins of bias, data bias. So AI models are often trained on data set that are not fully representative of all patient group. Yes, patients are unique, and history of every patient need to be known, and data may be disproportionately sourced from certain demographies. and leading the AI to underperform for underrepresented populations such as women, racial minorities, or those of lower socioeconomic status. So this data imbalance has resulted in misdiagnosis. That is the main point. Poor risk estimation or inappropriate resource allocation in past models. So historical inequalities also talks about the historical data used for training AI, which results or reflects in the systematic inequalities in healthcare, such as disparities in access, treatment, or outcomes. AI may reinforce these biases, prioritizing certain groups over others and to overcome this bias inequity. And algorithmic and selection bias. So algorithms can embed biases introduced during data labeling, model development, or evaluation process. So, for example, if model development excludes certain population subgroups or ignores relevant variables like social determinants of health, resulting AI recommendations may lack generalizability or fail to equally serve all patients group. In deployment and feedback loops, once deployed, biased AI can create feedback loops. So in that place, and the loops will misallocated resources or biased decisions further reinforce initial disparities, making it harder for disadvantaged group to access care. So this is the risks and disadvantages. So impacts of bias, misdiagnosis and substandard care, and inequitable resource allocation, and the erosion of trust. Misdiagnosis, yes, if the data used for training purpose misleads, means it will misdiagnose. So underdiagnose or overlook conditions in some of the groups, leading to poorer treatment and inequitable resource allocation. So biased algorithm may prioritize certain patients for treatments due to this biasing, and erosion of trust and engagement. This actual unfairness can lead to mistrust among patients and healthcare professionals, reducing engagement with AI-driven healthcare systems. So predictive healthcare logistics, it is applications include, that is predictive healthcare applications include demand forecasting and inventory optimization. So this is done by forecasting demand, anticipating risks, and enabling proactive resource management. So this approach, predictive approach, helps ensure the timely availability of medical supplies, equipment, personal equipment, protective equipments, reducing the stockouts and waste, while improving patient outcomes and operational efficiency. So these applications include the following mentioned: one, patient personalized care, treatment planning, real-time monitoring and decision support, and operational efficiency. And this is a comparison between the traditional versus AI-enabled logistics, in which various category of demand forecasting, inventory management, supply chain, route optimization, emergency response, maintenance, risk management, communication coordination, and cost efficiency. So the point is maximum 5 in the x-axis, and the traditional logistics is having maximum of 2, and AI-enabled logistics is maximum. So AI-enabled especially in the healthcare application, this is okay. And this is again category. These categories are compared with the traditional and AI-enabled. So this is in traditional, historical, and manual drive methods. In AI-enabled, the algorithms, real-time data integration is possible. Inventory management, manual, here automated. Supply chain visibility, periodic. Manual updates, fragmented information, here real-time, end-to-end visibility with IoT and dashboards, and route optimization, static route plans. Here dynamic AI and emergency response, slow manual decision making, here fast and data-driven response, and maintenance, schedule or reactive, here predictive maintenance from live sensor, and risk management, mainly reactive, here proactive, and coordination communication, manual calls, emails, delays, risks of miscommunication, here automated AI chatbots, and cost efficiency, higher cost from inefficiencies, delays, manual effort, here lower cost through automation, optimization, and reduced waste. So real world example, I show some of the companies and AI in action. So the company UPS, DHL, Mars and Celonis, Forkites, and Amazon. So see, these are the real world applications or examples of AI in action. And I Glovis. Thank you. Thank you all.